similar to the one we did in class, but we did it graphically, where a speeding car goes past a police car. In this example, it's a little different in that the speeding car does not even notice the police car. So it just keeps going 30 meters per second the whole time. It's got a constant speed of 30 meters per second the whole time, and nothing changes with the speeder. It didn't see the police car hiding in the bush. The next thing but what happens is that the police car sees the speeder. We're assuming the instant the speeder passes the police car starts to accelerate. So I'm going to put in blue here. This is supposed to represent the acceleration of the police car. And the question tells us that it has a uniform rate of acceleration of 2.44 meters per second squared. So every second it's gaining 2.44 meters per second. And so it's increasing its speed by that much. We know that the initial speed of the police car is 0 because it was at rest. And then it gets faster and faster. Eventually, so what happens is the police car is sitting here, the speeder blows past him. The police car starts to speed up, eventually overtakes the speeding car. The question is asking us at what point how much time and how far does it take for the police car to overtake the speeding car? So this is a tricky question because, again, we just don't feel like we have enough information. If we plug in everything we know, we'll say we know stuff about the car, the speeder. We know stuff about the police, right? So now the speeder is going at constant v, and this police car is accelerating. So in the case of the speeder, delta x, delta t, and v are really enough to describe its motion. We know that its speed is 30 meters per second. The police car, we need to know everything. Delta x, delta t, v naught, v, and a. We know its acceleration it's increasing its acceleration. If I define the positive direction to be forward, then its velocity is forward and its acceleration is forward, and it's 2.44 meters per second squared. We know it starts from rest, and that's all we know. So you can see there's huge gaps here. We don't know enough information. What we do know about this problem is that the distance each of these two vehicles travels is exactly the same. It travels a distance of delta x in getting from here to here. It also takes the same amount of time for the police car and the speeder. Like, this is just one time interval. So you can start the clock the second the speeder passes the police car, and then stop the clock the second the police car catches up to the speeder. And that's just 1t. So what we're going to do here is this trick where if we don't have enough information, but we know these two things are linked together, we can just give them a variable name. We can just call the distance the speeder travels x, and it takes a time t to do that. The police car travels a distance x and in a time t as well. So this becomes my don't know, don't care, and we're going to try to work it out from there. Now, we can set up our equations. Well, I don't know these variables, but I do know that delta x equals v delta t, so I can just write this equation as x equals 30t. Two variables, one equation. But it's not terrible because we have another equation we can generate here. My v is my don't know, don't care, so my equation I start with is delta x equals vo delta t plus 1/2 a delta t squared. Since v naught is 0, I'm going to cancel this whole term out, and I end up with just x equals 1/2 of 2.44 times delta t, t squared. So I end up with x equals 1.22t squared. So you can see that what I've done is I've generated two equations, and I have two unknowns. So now I just have to substitute and solve. I can do this by setting them equal to each other, right? Equal. So set equal. I can do that by saying 30t equals 1.22t squared. Now, in order to solve this equation, I can do it a couple of different ways. Mathematically, the way you'd probably do it in math is you'd set it equal to 0. So 0 equals 1.22 t squared minus 30t. And then you can factor out a t, so you end up with t, and then 1.22t minus 30. So then what we're saying, in order to solve this equation, we have two things. T equals 0, or t, sorry, I can say it like this, 1.22 t equals 30, basically. So t equals 30 divided by 1.22, and that equals 24.6, around 24.6. So let's look at what we have. What these equations are telling me is that the time at which the police car and the speeding car have the same delta x, or the same position, is either at 0 seconds or at 24.6 seconds. It makes complete sense because they are at the same position at t equals 0. They're both at 0. And at 24 seconds, they're both at this distance, delta x. So the answer to this question, where does the police car overtake the speeding car, is after 24 seconds. It overtakes the speeder 24.6, I'm off the page now, 24.6 later. And that's good enough. All right, so then finding delta x is really simple because we're just going to plug it into this was all for solving part A. And for solving part B, it's easy because we know that x equals 30t. So we're just going to set 30 times, and I'm going to use my unrounded number, 24.59, 24.59, and when I do that, I get 738 meters, 738 meters, so almost 3/4 of a kilometer away. It overtakes the speeder 738 meters from the beginning, or from the spot, from the initial spot.